Hello everyone. Hope you all doing well and staying safe. Just to give you a quick introduction myself, my name is Rizwan bin Suleiman and I am PhD student, as you might all aware, at University of Bedfordshire. And as you all might aware, Dr. Whitley is my supervisor as well. So this is going to be a very short video to just give you a brief idea about what I'm intended to complete my research on, and this is going to be give you an idea about how I'm working and what things I'm working on. As it's my first year and still there's a lot more to be done, but whatever I have done so far, so you all guys get an idea and might get a good motivation out of it. So the topic I'm working on is machine learning applications, and I'm just making it more narrowed down to use these applications for fraud detection. So today in this video I will be covering a few table of contents, including abstract introduction, problem statement and motivation behind it, technologies being used and what we'll be using in the future, a data set for credit fraud detections, data flow diagram, progress of applications, various advantages of using the technique, system requirements. We would also talk about the conclusion and the future scope. So starting from the abstract, as you see, the world is moving into the cashless society where various companies in all sectors, medicine, retail, industries, they've all been moving from cash to credit cards. And as this trend is increasing, the use of individual based on the ATM machines is getting increased if they need any cash. End of the day is all about the cards, is all about the bank's transactions, online transactions, physical cards and all these things. So while this technology is bringing a relief in the daily life for the people in terms of their shopping and everything, while on the other hand you're increasing opportunities for other people who are used to create problems in the normal legal system, where comes the concept of fraud. So credit card fraud is increasing on daily basis based on the usage the people are using and all the transactioning happening all over the different sectors. So billions and billions of dollars are lost every year, and investors in the companies are putting more and more investments to cope up with the challenges caused by this credit card frauds. So as I mentioned, the online shopping is becoming a very common all over the places. We talk about the UK, the financial the latest stats which shows the National Crime Agency the lost $190 billion the pounds recently due to the financial fraud. And the UK Finance Report Bank says they have blocked around £1 billion organization blame caused by the credit card frauds, and got the cross loss of gross worth of around 455.8 million alone only in the UK. So as you can see the figures, this is just an example. There are a lot more figures which I mentioned in my report, which shows there are serious loss of money and a lot of financial threat to the potential in the very near future. So in the next slide now we can see the problem statement and motivation. What are the major problems behind this credit card scenario, and what is my personal motivation to carry on my research in this area? First of all, let's try to understand what is the problem in credit card. So fraud. So credit card fraud, we need to understand that there is a word called heterogeneous. So heterogeneous literally means that all the frauds that happens in the credit card, they're heterogeneous. That means that these frauds are the system is so complex in terms there are various organizations of credit cards, there are various locations where these cards have been used, and there could be various currencies where these credit cards have been used. So all these things makes this system or the whole credit card system so complex, and it becomes a really difficult to identify the frauds happening in all this heterogeneous environment. And this leads to a problem of imbalanced data. That literally means that we don't have any organizing of the data in a certain order where we can just work on and identify all the main frauds that's been happening. And there is a big, as I said, a big ecosystem of having a large transaction happening all over the regions of the globe, all of the big organizations doing their transaction their own ways and in different currencies. So these things makes the things very complex, and it becomes really essential to work on that. So as I said in the third objective, where multiple objective optimization criteria are there as well. So the lack of testing and all these things. So based on all this kind of scenario, it's been my motivation, and I've been doing all these security certifications, and even doing my masters. I work on security projects. So this was all my motivation to understand the heterogeneous complexity of the my credit card fraud and work on my research. And another thing is very important to know about it is this credit card heterogeneity is not just to up to a certain level. However, it's continuously in an evolving phase. This fraud and this complexity is increasing day by day. So it's really essential to understand and bring up some standards which companies and organizations should follow to cope up with this potential challenge. Okay, in the next slide here you can see fraud detection process. So let's make it a very simple to make you all very clear. I'm trying to be very generic and try to be simple, big things putting in a simple so you all can understand in a well-mannered way. As you all take an example, you go to the retail store, any small grocery store or any other shop. You all aware of the terminal that you normally pay. If you don't have a cash, you just pay with a card. With either you just swipe it or you ask for the you insert it in, and also the pin and chip and pin. That's all you do to do the transaction and get your products. So let's try to understand how the system works, the detection system in this whole process works. So let's start from the slide. The flow thing you can see on the left, right? If you do swipe your card in the terminal, what it does in the background, it checks if the pin is correct or not. If it's not correct, it rejects, and also it also checks if you have the card is correct, if you have a sufficient balance, if the card is blocked or not, or anything like this, the basic checks. So let's suppose if the card is right and the pin is wrong, it will reject the card, it will reject the transaction. At the same time, if the pin is right but the card is wrong, still it will going to reject the transaction. And now if the correct is the pin and the card is correct, if both matches, then it goes to the next process where you can see on the slide, which is called predictive model. And this is basically a machine learning model. And let's go down, and you would come to know what it actually does. So this machine learning got the transactions where your pin matches with your card, and this predictive model we're gonna go down to score, which is called as fraud score, where it will check the level of potential fraud that can that might be taking place at the back end. It could be anything. It's not linked with the chip and card, but it can be linked with many other things. It's been stolen, or it's been having another history at the back of the card. So this fraud score will give a certain number, a certain allocation of tag to that transaction, and that is followed further down to the investigators, which are the human based. So these investigators look at the fraud score. If it's too less, of course they have certain standards. If it's less than that standard, they just go ahead to carry on with the transactions. However, if the score is too high, that means there is a more chances if the card is there's a fraudulent activity with the card is going on, then it can be rejected by the investigators. So let's suppose in this scenario everything is fine, investor investigated, and they said that the check card is correct, like the keep that green signal to go the things further on. So based on the feedback from the investigator, the process is followed again to the predictive model, which is a machine learning model, and it goes hand back to the allow the transaction to go ahead. So this predictive model now knows that this card we already been checked, already been investigated, and this is good to go for the next time when this transaction going to happen. So this predictive already learned the whole scenario of this transaction, and it will carry on with faster in the very next time. In the next slide, as now you can see, I'm going to tell you what technologies would be using. So based on the last slide where you can see the predictive stage of the system of fraud detection, so here I'm going to elaborate you more what that predictive thing do, how it do all the learning process and pass to the fraud score related to the investigators. So the technologies that being used there is artificial intelligence. So once we talk about the artificial intelligence, that's sort of a very broad category. So under the artificial intelligence, all rest of the things comes up as you can see on the slide, which includes machine learning, deep learning, neural network, and data mining. So if you look at the machine learning and deep learning, so I just arranged them in an order you can see. So deep learning is actually the sub branch of machine learning. Same time, neural network is a branch of deep learning, and data mining is further branch of data mining, and artificial intelligence is a big space, which umbrella which covers all these four technologies. So today we're not going to talk about all of them. So the one I would be talking about is machine learning, and machine learning is further categorized, as you can see on the slides, in the use of various the learning algorithms, which are supervised learning and unsupervised learning. So supervised learning, you can see they are further categorized into classification and regression. So in the same time, unsupervised learning further divided into clustering and dimensionality reduction. And the last one, which is here, is reinforcement learning model. So they got a different bubbles further down, classified into. And the last one, which is here, is reinforcement learning model. So they got a different bubbles further down, classified into the various small bubbles, but we're not going to talk about all of them because they are just out of scope for now. I mean, what just been covering today is regression, as you can see there. I'm going to talk about in the later part of the slide. So in the next slide, we talk about machine learning and the two further classification, supervised and unsupervised. So let's talk with the supervised learning first. So in a simple words, let me try to explain you what supervised learning is. In a simple, very simple terms, your supervisor, your teacher, whatever the task he or she gives it to you, that's what you're supposed to do. The same happens in the machine learning terms of supervised learning, where you give a data to the machine learning algorithm. There are two sets of data. One is called training data, and the other one is called test data. So in the training data, what it happens is once you actually train a system, you give a data to a system and you train the system, and once you train the system, it is capable of doing that task. And at the same time, the testing data is on the other hand is used to test the data which you have provided in the training data. So unsupervised learning on the other hand is different. There's not any kind of person or anyone to give training to a machine algorithm. However, these algorithms are clever to classify the data itself where you just have to provide the data to the algorithm, and it basically classify all the data orderly, all unlabeled data by itself without any supervised approach. So in the next slide, I will show you some of the framework, the thing which I have done in the Jupyter notebook. As you can see in the top left, where it shows which I have imported the libraries in the Jupyter notebook, and once I have inserted of course the libraries, these are based on the various Python and other scripts which I won't gonna go into the depth as it's gonna be out of, I don't want to make it too difficult to, but just assume that is libraries which I have inserted. And in the next right top you can see the I inserted two set of data, class 1 and class 1 and class 0, sorry. So the class 1 is the data which is fraudulent, and you can see the bottom length fraud, which is 372, and the second one is the normal data which is around 190,683. So you look at this number and you can just assume like how imbalanced the whole credit card transactions are and how difficult it is to recognize them on an individual basis, and it becomes so complex. And at the bottom left you can see like a graph where you can see like a blue bubble. So there's a data which is normal data, and those orange dots, those are the fraudulent data. And you can see at the right bottom where it shows the results while having these two set of data, fraudulent and the normal. You can see the output based on logistic regression, that it has produced a quite good results out of it, quite accuracy. Of course it still needs to be improved and still accuracy needs to be enhanced. However, the output shows that logistic regressions, by using that, it has quite produced an improved results. Yeah, so as you can see on the results which we have used with the help of logistic regression algorithm, that it's quite been improved, and we can say, like I can say from my perspective, that this has been one of the best compared to other algorithms. Right now the result I have gained based on my research so far, and of course based on this might be I'll come up with something new combination of algorithms in the future. However, so far this is my findings and research on logistic regression. Okay, so I know the video is getting a bit longer, and let's try. I'm just going to conclude very shortly, just to get you a bit of idea about methodology I have used for all this process. So methodology, as it's mostly you must be aware while doing your bachelor's and master's, what we do is the problem identification. The first one, you collect all the unstructured and raw data, you which I have done the next part to download the data from Kaggle. I know you bit complex words for you to understand, but it's a place where I have downloaded. I've used the libraries based on Pythons and alls. Next, which followed with the pandas and NumPy, Skeleton, etc. Process the data for analysis. I have used perform the logistic regression on data and explore the data as well, and I perform the depth analysis of all the process of analysis, and I have definitely communicated results after analysis being made. So I'm just going to go very quick with the system requirement based on the hardware. RAM I have used at 4 GB, could be higher. A processor for me was Intel i3, could be above. Hard disk I have used 500 GB. That's a minimum. As much as you can use is better, and the faster it could be. And based on the hard software I have used Windows, it could be Linux as well. I use Python IDE 2.7, could be above, and Jupyter Notebook I used for import libraries, setup tools and pipe install for the 3.6 and above. and the language of course is a Python I've used in my regression. So guys, I just come with the last slide, which is trying to conclude everything in one slide here. So let's tell you the overall conclusion I have done so far for my PhD PP1. So my ultimate goal is to use the combination of algorithms for fraud detection. On the slides I have explained you logistic regression. However, so guys, I just come with the last slide, which is trying to conclude everything in one slide here. So let's tell you the overall conclusion I have done so far for my PhD PP1. So my ultimate goal is to use the combination of algorithms for fraud detection. On the slides I have explained you logistic regression. However, in the future, when my research goes further up, I would be combining it with other algorithms as well, which I'm still working on to get the higher accuracy for fraud detection mechanism. So as you have seen the stats, I try to make you aware of different approaches and methodology being used in machine learning. And of course, this is my first year, and still a lot more to be done in terms of implementation and everything. So well guys, thank you very much for your time, and if you have any questions, please feel free to contact me anyhow. And then the last, these are all the references. Thank you very much indeed.